Hi, Mr. X with glossary term derivative. In calculus, the derivative of a function gives us an instantaneous rate of change between the two variables if we have a two-variable function. And when we learn about these things, we almost always say y equals f of x so we can keep things straight. So when we take this derivative, what it provides is the slope of the line that is tangent to the original function, like this. Some function streaking across the sky here. Well, it's not the sky. This is just a function. X, y equals f of x. Here's a function. So what would be the tangent to the function at, say, I don't know, let's say this point right here? Well, what we do is we take 2 points really, really close to one another, and then we examine the straight line between them. So we're going to put our magnifying glass on here. We've got a little magnifying glass to zoom in on it, and here's what it looks like. Now these are the same 2 points we had a second ago that were right next to each other. We let this delta x get to be really, really small, which means this is going to get pretty small as well. But they don't actually go to 0, they just get really, really small. Not 0, just a little bit above 0. Well, then we have this relation. And this is our dy, this is our dx, in effect, at least that's the way we engineers look at it. And so what's dy dx? Well, that's the slope of this line. It's the slope of the line between these 2 points. Because here's the point we had an interest in, and this point would simply be x plus delta x, y plus delta y. And since this delta x and delta y are incredibly small, then dy dx gives us the slope of the line in between. You have to think small to think big in calculus. On the World Wide Web at mrxmath.com.